This video presents two more examples of the independent t-test using SPSS. We want to know whether men and women differ in the amount of change they carry around with them. We draw a random sample of men and women and ask them how much change they currently have on them. The null hypothesis is that the population means are equal, or that there is no difference in mean amount of change between men and women. The research hypothesis is that there is a difference between the population means. We'll use a significance level of 0.05. The dependent variable is amount of change measured in cents, and the independent variable is gender. Looking at this table, there does not seem to be a difference, but we rely on the t-test results for making this decision. The p-value for the Levene test is large, so the equal variance assumption has been met, and we can interpret the top row of t-test results. The p-value is large, so we don't reject the null hypothesis, and the analysis ends. In our summary, we say that there is no significant difference in mean amount of change carried between men and women. Let's say that we want to know if women pay more than men for haircuts. Based on our extensive previous research, we have reason to believe that they do pay more. The null hypothesis is that there is no difference between population means, and the research hypothesis is that the mean cost is higher for women. We'll draw a random sample of men and women and ask them how much they paid for their last haircut. The descriptive statistics show a striking difference between groups in both mean and standard deviation. The p-value for the Levene test is less than 0.05, so the equal variance assumption is not met, and we interpret the bottom row for the t-test results. The p-value for the t-test is very small. Double-clicking in this cell will reveal just how small it is. Because this is a one-tailed test, we divide the value in half, but would report it as being less than 0.005. The degrees of freedom are always rounded to the nearest whole number. We would conclude that women pay significantly more for their haircuts than men. The results were statistically significant, so we would also estimate the size of the effect. We don't interpret the confidence interval from SPSS because we did a one-tailed test. The rejection region was in the upper tail, so we would create a lower bound on the estimate. The mean difference and standard error are found in the table, and we look up the value for t in a table of critical values. This gives us a lower bound on the estimate of approximately $14. Because the equal variance assumption wasn't met, we interpret Glass's delta, which uses the control group standard deviation in the denominator, and the mean difference in the numerator. A standardized effect size of 1.85 is large. In addition to reporting the t-test results, we can say that we are 95% confident that women pay at least $14 more, which is a large effect size. The independent t-test is used to test hypotheses about two independent population means. If the equal variance assumption is not met, we use a separate variance procedure, which is sometimes called Welch's test. The degrees of freedom for this test are determined differently, and the value is rounded to the nearest whole number. Effect size provides an estimate of the magnitude of an effect or difference. The two types discussed here are estimation and the standardized effect size. If a one-tailed hypothesis test leads to a statistically significant result, the follow-up confidence interval should also be one-tailed.